Before we jump into the course, I need to give you some additional information. So all techniques are grouped in two separate subgroups. One will cover persistence methods that do not require local admin privileges, and the second will cover the rest. In your course materials, you will find C code templates with a text file containing all commands used during the course. So you don't have to worry about the syntax, okay? Third thing you have to be aware of is that some techniques will run your payload multiple times, meaning that if you want to use them operationally, you will have to implement some additional control mechanism for spreading using stuff like mutexes, files, events, or something similar. So code course doesn't have that, but it's pretty easy to implement such control using Windows API. And speaking of payload, for the exercises, I'll be using standard simple shellcode which spawns a notepad process, but with provided code templates, it will be super easy for you to reshape the code and use something more realistic. For example, Meterpreter, Empire Beacon, or any other payload you commonly use during the operations. And at the end of this video, I'll show you the implant code used in the course. The next thing, after every shown technique, I'll be doing a cleanup so we don't end up with several implants popping up simultaneously, okay? And I encourage you to do the same. And the last but not least, each technique will be preceded by an intro slide describing the name, the required access level, and which thread group or malware used this particular technique. Okay, let's take a look at an example. So used by section will contain thread actor names like APT28, Cozy Duke, etc. Everyone means that the particular technique is very popular, okay? And unknown means that the technique is either not known or I haven't found too much information about the threat actors who use it. And here's an example. So the name of the technique is Local Security Authority, which needs local admin privileges, okay? And was used by Flame malware in a particular technique using authentication packages. Equation group used that in Dark Pulsar by implementing a security support provider, okay? And Project Sauron used password filter for that technique. So let's take a quick look at the implant code used in the course. So in your course material, you can find an implant folder, okay? And it holds several files: implant.cpp, implantdll.cpp, and implantsrv.cpp. So these three files contain a C code, which will generate, the first one generate the standalone exe file, DLL will generate a DLL, and this is going to generate a Windows service. Okay, so let's take a look at the source code of implant.cpp. And those of you who took other Red Team Operator courses like malware development or local privilege escalation should be familiar with that code because it's pretty much the same. So what we have here, we have a simple main function which will start our payload either from the which is encrypted by the additional Python script, or we just start Notepad, like creating a new process calling Notepad. But if you need to weaponize that script, you can use that comment out code, which will take your payload and decrypt them and just run it in a separate thread here. So we resolve two functions, virtual alloc and RTL move memory. Then we we allocate new memory, we decrypt our payload, and we copy that payload into allocated memory. Okay, and then we change protection settings on that allocated memory to execute and read. And if all is successful, then we create a new thread calling that payload, decrypted payload. So where is the payload? Payload is here. So it's a long string, okay, byte string, and a key is here. And AES decrypt function is defined here, so we use crypt API, Windows API, to decrypt the payload. And if you want to encrypt your payload, so the payload we are using in here is actually this one, which spawns a new thread. Excuse me, it spawns a new process, in our case a notepad. And but you can use that using this AES Py script, and use it is really simple. So you call Python AES and the name of your payload, which has to be in binary form. So if you use meterpreter, for example, you have to generate the meterpreter in a raw format and save it in a file, and use that as a parameter for the script. And when you run it, you get two variables, two results. So this is your key. So you take that and you just copy that here into this key line. And the same goes with the payload. So you just take that part and copy this into this line. And you save that and you should be good. So that's the payload we are going to use during the course.